Hello everyone and welcome to this webinar session about midas and effects. So before we begin the session, I'd like to be sure that you can hear my voice, so if you could just leave a message in the chat section and I will start right away. Okay, so welcome everyone. We have a lot of people today for this second session of the heat transfer webinar. So we'll talk today about how to handle the heat transfer and the thermal stress simulation in structural analysis. So we'll see first what are the benefits of the simulation for the thermal analysis. Then we'll talk about what different kind of engineering problems that can be solved using thermal simulation. We'll talk about the design validation for thermal analysis and heat transfer fundamentals and thermal stress. And finally, we'll talk about what kind of software do you need to analyze properly and do your thermal design. And finally, what are the problems that can be solved using midas and effects. So to begin right away with the evolution of the design process. So as you may know, the traditional product design process involved a lot of experience and a lot of prototypes because it's a trial and error system. So you do a lot of prototypes, you do a lot of tests, and finally you get the most satisfying product. So the cost is quite high usually, and this is why simulation-driven product design has been invented. So using CAD and simulation together, the computer gives you the right inputs and the optimization that you can bring to your model. So you only need one prototype and one test, and then you can save a lot of money. Now, what kind of engineering problem can be solved using thermal simulation? So first you have, in electronic products, the heat and thermal analysis is used very intensively. You have a lot of problems like the overheating of electronic parts, and usually you have also lack of dimensional stability, some excessive thermal stresses, and also other problems related to the characteristic of the material. So in the right side you see that there's a design of a heat sink. So it's a simulation quite easy to perform, but it really gives you a lot of insight about your modeling. So for example, before the simulation, the maximum temperature was 176 degrees Celsius, so it needed to be redesigned. But after simulation, the accurate design made its temperature decrease to 132 degrees Celsius, and it fit the requirements. So you have also a lot of challenge for the cooling of electronic device. Because all the PC boards become smaller and smaller, and you need to have powerful fans to remove the heat. So at the same time, simulation allows you to simulate all that directly on your computer. You can just use a fan model and define your fan curve, and it will then tell you how and how much time it will take to cool the system. Thermal analysis is also used a lot in machine design. So for example, engines, hydraulic cylinders, electric motors or pumps, and processing equipments. You have an example of pump here. So what is affecting the pump is that some thermal effect may cause excessive stresses and deformation inside the system. So in this case, inside the bearing. And you see that the redimensioning and designing with simulation helps to reduce by almost 15% the temperature. Now, in automotive industry, heat and thermal analysis is used for brakes, motors, hydraulic pumps, and also lamps. So you have some, so it helps to improve the thermal performance, also to avoid the overheating and the thermal stresses. So you have an example here of a car lamp. Now let's see how you can use simulation to validate your design. So first of all, if you are already a structural engineer or you have some experience with structural simulation, thermal simulation is very simple because it's a simple analogy of structural analysis. So for example, temperature is equivalent to displacement, temperature gradient is equivalent to strain, and heat flux is equivalent to stresses. So in linear static heat simulation, the equations are the same, so this is why you have very similar phenomena. Now let's talk about the three main characteristics, the three main mechanisms that are defined in the heat transfer. So first, the conduction, which is responsible for the heat flow inside a solid body. So you can look at the image on the right. You have conduction of the hands with the handle. So you have a direct contact between the two objects. So this is called convection. Then the conduction, sorry. The convection is responsible for heat entering and escaping a solid body. So generally it's used to model the interface between a fluid and a solid. So like in this example you have water, but it could be air around the solid as well. And the exchange of temperature with the solid part and the water, it's called the convection. And finally, you have the radiation, which is responsible for the heat entering and escaping a solid body. And heat transfer by radiation is always present, but it becomes noticeable only at higher temperatures. So you'll understand why when I will show you the simple equation. So the need for the thermal analysis is here because you can easily get the temperature using the simulation. You can easily capture the changes into temperature. And all that is very difficult to test. So if you have to do real live testing, you'll take a lot of time, a lot of money, build the prototypes and everything. But simulation, you have that directly. So it allows you to modify your design before building any kind of prototype. So this is why it saves a lot of time. Now let's talk about a few fundamentals of heat transfer. So I told about the three main types of heat transfer. So let's just describe a bit more in detail. Conduction, which describe the heat flowing inside a body. So if I give you a simple example, like this heat flow across a wall, you can imagine you have the wall, you have the hot temperature, and you have the cold temperature on the both sides of the wall. Conduction is defined like K multiplied by A multiplied by the difference of temperature and divided by the wall thickness. So A is the area of the wall and K is the thermal conductivity. So thermal conductivity varies in function of the material. So if you have a metal, it's a conductor, so the K will be high. And if you have a foam, it will be insulator, so your K will be very small. Now, what about convection? So convection describes the mechanism of heat exchange between external phase of a solid and the surrounding air or fluid. So it can be air, it can be steam, water, oil, etc. So you have example here, the airflow along the wall. So you have the air which is going, so the hot air is going up and the cool air is going down, so due to the gravity. So convection is linked with gravity. So the basic formula is like H multiplied by the area of the phase exchanging the heat and the difference of temperature between the surface of the wall and the temperature of the fluid. And again, the H coefficient, so which is called convection or thermal coefficient, it depends actually on the case. So if I take air, if I have natural convection, you have H between 5 and 25, and if you have forced convection between 20 and 300. So what are natural and forced convection? Maybe you're not familiar about these terms. So natural convection is when you have a body and you just studying what is the natural, let's say, flow of temperature around this body in normal conditions, let's say. For example, this model is an LED model, so in the air, and then you want to see what is the heat going around the LED, so how it will make some influence on the environment around. And forced convection is actually forced, so this is what I call forced convection, by fan, for example. So you put a fan and you want it to cool it quicker than usual. So because of you doing that, you have a strong air flux around the parts, and it makes a higher convection coefficient, and so you have higher cooling rate of your card, and this is what we investigate into forced convection analysis. Now, radiation is the heat transfer phenomenon in which you have transfer of energy under the form of electromagnetic waves between two separate objects. So you have, for example, a chip. So you have a source, and let's say you have nothing inside, but you have some transfer of heat between the chip and between the, let's say, the cover of the chip, And this is called radiation. So you have radiation, it can be sun radiation as well, so you have the rays of the sun are also heating your model. And so it depends on the temperature. If you have a low temperature, it will not do much, because as you can see here, the temperature has a power 4, so it's a nonlinear type of interaction. So if the temperature becomes big, the team will become very important, and then you have a lot of exchange of heat. So it's only when the heat is very important in your model that you'll have to use the radiation. Now comes the funny part. So I'll show you how to do a simple heat sink design into midas effects. So with 3 models, so the basic one, and then how to do it quickly with another 2 designs, so design 2 and design 3. But what is funny is that you will be able to do it by yourself as well, directly online in your browser. So for that, you can go to this link, midasnfx.com/heatsink. So you can do it right now while I'm doing the demonstration by myself, or you can also save this link and do it after the webinar. Maybe it will be more convenient. It depends on what you want to do. So please just note it. So I leave you 1 minute to note the link, midasnfx.com/heatsink. Then the only thing you have to do is input it in your browser, and you can start the simulation directly. So you don't need to install the software or anything. So I'll leave you 1 minute to take a note, so you can try again after the webinar. And if you have some questions, or eventually you can always ask in the chat section. So it's live, so you can. I will answer your question directly. Okay, now let's try to do it into midas effects. So I open the software like that. Sometimes I have a small problem with the window of. Okay. The size. Okay. Now I'll do this simulation. So I open a new project into. I will walk into the designer mode because I'm designing the heatsink. So I will put it first into meta unit, and I will import my model. So I use the sink. So you see it's a very simple part. So it's only constituted by the sink and the chip. So I can go in the model. So I have two parts, the chip and the sink. So it's very simplified to show you how it works, the process. So first thing I'll do is just create some material for my model. So I add some material like that. So using the material library, I'll go in all the non-metal tab and select the ceramic porcelain will be that would be associated to the chip. I click on apply and you see it's added here in the walkthrough. Now let's use aluminum alloy for the sink. Okay, now that I did that, I have to assign it, so I drag and drop it on my model, and this is all I have to do to assign it. Now that I did that, I have to input the loads on this model. So let's just hide the sink and assign the temperature to this part. So let's select the faces. So let's select the faces of the chip and input 80 degree. Click on OK. Now let's open the sink and hide the chip. And here I will assign some convection. So convection will represent the flow of the air around this. So I have to unselect the parts of the sink that are in contact with the chip because they are not in contact with the air. Then I input ambient temperature of 25 degrees Celsius, and the film coefficient will be 25 also. And just click on OK. So I created the convection and I created the temperature. So now let's just mesh it. So let's create auto mesh, select all that. So in one simple step I get my model mesh with the boundary condition. Now let's create the analysis case. So give it a name, case 1. And now I have to choose the type of analysis I'm doing. So it's called nonlinear static heat transfer. So it's actually linear, but it's called nonlinear because in case you have radiation, it becomes nonlinear. So this is why it's called nonlinear. But if you don't have radiation, it will be solved linearly. So I get that, and I only have to perform the analysis to get the result. Okay, so you see in 3 seconds I get my results. So I have temperature, I have the solid thermal gradient and the heat flux. So if you want to check what is going inside, you can just use this and drag and drop to see the distribution of temperature in the heat sink. And now what I want to do is, I have several prototypes and I want to test all that. So rather than just doing all these steps again, let's just open a new project and do it quickly. So I'll do it with two designs. So let's import the second design, which is like that, and the third design. So I got my 3 designs. Now let's show them in the same window. So you see, you can see the same model in one window, and you have the analysis I created in this model. So I only have to drag and drop it on the 2 other models like that. And after that, I just click on solve, and you will see it's magic. It's meshed automatically, and then it runs the solver. Okay, finished. So let's do the same with this model. Okay, now let's show the 3 model again, and if you check the result, you see that I only did a few more clicks and I got the results for the 3 design in just a few seconds. So this is why it's efficient to use the designer mode of midas effects, because you can have directly like that the testing of your different prototypes. So if you want to get, let's say, the value of the result, you can, for example, use, let's say, a probe tool, and you get the temperature at any position of the model. And you can also export the graphs. You can create 3D PDF, for example. So I'll show you that. For example, you click just, sorry, okay. You have Word formats, etc. Okay, and you can. So when I'll go back to PPT and check. Okay, so if you want to try that back, you just have to import this link into your browser, and you can try by yourself. So okay, now let's go on and talk about the thermal stresses. So thermal stresses are actually created by heat. So when you have a solid body, it can change the shape due to the temperature. So temperature will make that the body will expand or shrink, and this will cause stresses in some parts. So for example, you have temperature resultant from the heat generation of the chip, and then if you do the thermal stress analysis, you'll get the stresses into the pins of the chip. So it'll tell you exactly what is the danger of your design, in which parts it will create stresses, so you have to redesign all that. So good thing is that it's not only in linear way, so in midas NFX you can also simulate nonlinear type of interaction between temperature and stress, so you can use nonlinear quasi-static, and you can also perform that together with thermal. Now, what are the capabilities you need for such kind of thermal analysis in the software? So if you're searching for design validation software, you need all these points. So first you need to be able to simulate the 3 main type of heat exchange: the conduction, convection, and radiation. So this is mandatory. Then if you want to, not if you want, but it's also very useful to have thermal resistance between the layers. So if you have several parts, you may have some resistance between 2 parts. So this is simulated using thermal resistance. Now you have time-dependent thermal effects like heating and cooling. So your software should be able to simulate that as well. So it's called transient thermal analysis. And all the features like the temperature-dependent material properties, so if you have material which have properties which change with the temperature. Heat generation, very important. Convection coefficient and other boundary conditions also that can depend on the temperature and the time. And natural and forced convection analysis also is useful. If you have to do that, you need to have heat flow coupled analysis, because this is actually analysis coupled with flow dynamics, with CFD. So midas NFX can do that. You have a full coupling with heat and flow together. So you can simulate natural forced convection. You can use fans. You can also use a lot of cool things that we added recently, like porous media and the MRF, if you know what it is, etc. Then coupling with structural analysis if you want to calculate the thermal stresses, so steady state or transient. So these are all features needed. And in addition to all that, midas NFX advantage for the thermal analysis is that it has a very simple interface divided between the designer mode and the analysis mode. So if you are a designer and you need a very simple tool to go with your analysis, and just to get the result you need, you can use the design mode. It's very simple. And if you are an analyst and you are you know about more advanced feature and code, you can use the analyze mode. NFX fully supports master models, for example, so you can import your model from master file and get the analysis to run. It also supports certain CAD models types. So if you have your own CAD software like SolidWorks, Autodesk, Inventor, or any type of software, you can import your model inside midas NFX. You have designer to update, so this is what I showed during the presentation, that you can just use simple function drag and drop to update the design. And then powerful multiple measures and solvers, and we also added the GPU calculation using the graphic card processor unit. And finally, you can do automatic reporting like the Word format or the 3D PDF format. Now, how to get more training material on software, and how to get more online experience. So if you want to test the other features of the software, so not only the demonstration that I did today, you can go on this page, midasnfx.com/FEA, and then you will be able to try online in your browser these 4 different types of experience. So structural analysis, optimization, thermal analysis, and CFD. So it's very interesting with very nice advice about analysis, and it will show you exactly what you need to perform for operation to get your result, and what kind of benefit it gives for your design, for example. Now, thank you very much for attending the webinar. So my email is at the bottom, cyprian@midasit.com. So if you have any question about this webinar, you can either send me an email or you can ask right now in the question section, and I will answer in live. So moreover, if you're interested, for next webinar is on the 28th of October, so it will be about fast dynamic analysis and crash analysis. You can also join us on social networks. Okay, so let me know if you have some questions. Okay, I got some questions. So can we change the mesh size in this model that you showed during the demonstration? Yes, of course you can. So let me come back to the software to show you that. So this is the analyze model that I performed. Now let's say that I want to go back. So the mesh size is a bit short here, so I want to make it more accurate. So the only thing I have to do is go back to the geometry tab, then I will delete mesh, and I just have to run again the measure, so I can select a very small mesh size. I click on OK, and you see that the mesh is regenerated automatically. So after I did that, I just launch the analysis again, and I get my results with more accuracy, let's say. Other questions? Okay, I have no other questions about the defeaturing of the model. So yes, midas NFX can do that. So if you have a CAD package, for example, and you import it into midas NFX, then it will obviously happen that your model is not really suited directly for simulation. So you'll have to simplify a bit your model. So let me show you some example. So if I have, for example, this. Okay, so I have this model, this thing design that I just imported into my CAD. And if I look, so it's not a big problem in this case, but it can be and it can go wrong mesh, you can see that there are some lines here that are not really needed in my simulation. So I just want to remove that. So I go in the Simplify tab, and here you have manual simplification. So I remove face, and the only thing I have to do is select the face I want to remove, and you see that automatically you have a very clean model of simulation. So if you do that, you can directly run the simulation again, and it will give you better results. Any other questions? Okay, I think it's all for the questions for the moment. So if you have more questions after that, you can always send me to my email. And I hope you had a great time in this webinar. And if it's interesting for you and it's helpful, then we are happy. And I hope you will join the next sessions and eventually also share with some of your colleagues and friends if you think it can help them to solve their engineering problems. Thank you very much, and see you next time.